Good day everyone! Welcome to Modern Physics channel. On this video, we will talk about special relativity. This is Leo Sinelio from BS in Science 3A. On this part of the video, we are going to talk about the relativistic energy and equivalence of mass and energy. Mass-energy equivalence states that mass is concentrated energy. In his theory of special relativity, Einstein formulated the equation of E is equal to mc squared. Alright, so in relativistic energy and equivalence of mass and energy, we have two formulas or equations being used, which are the relativistic energy and the kinetic energy. Relativistic energy is equal to mc squared. M is the mass of an object and c is the speed of light that is being squared, divided by the square root of 1 minus v squared. V is the speed of the object that is being squared divided by the c squared, or the speed of light. And second, we have the kinetic energy is equal to the relativistic energy minus me c squared. Me is the mass of an electron or protons, depends upon the given problem, and the c is the speed of light that is being squared. We're going to answer our first problem. We have here an electron moves with a speed of 70% speed of light. So find its total energy in electron volts, or EV. We're going to identify the given values. Alright. So first we have an electron. So electron, the mass of an electron is equal to 9.11 times 10 raised to the power of negative 31 kilogram. Alright, so we have also the velocity or the speed of light, that is v 0.70 c, or 70% speed of light. And we're going to find its total energy in electron volts, and EV. So now we have the given, we're going to plug in all the given values to our equation. So we have here E is equal to M, mass of an electron. We have 9.11 times 10 raised to the power of negative 31 kilogram, multiplied by the speed of light, that is 3.00 times 10 raised to the power of positive 8 meter per second. And let's copy this is the squared, divided by the square root of 1 minus the v squared. V is the 0.70 c squared divided by the c squared. Alright, so let's just copy the c squared. Next, 9 alright, so here we are going to square the speed of light first. So we have here 9.11 times 10 raised to the power of negative 31 kilogram, multiplied by the product of 3 times 10 raised to the power of 8 multiplied by itself, that is 9.0 times 10 raised to the power of 16 meter squared and second squared. Alright, so let's multiply this one and divided by the square root of, we have here 0.70 c multiplied by itself, so we have 0.5 49, and c multiplied by c is equal to c squared and c squared. So let's cancel out the same unit. We have c squared and c squared. So let's get another piece of paper. Now, we have here so 9.11 times 10 raised to the power of negative 31 kilogram multiplied by 9.0 times 10 raised to the power of positive 16 meter squared second squared is equal to 819.9 times 10 raised to the power of negative 16, because we have here negative times positive, so negative 16 kilogram per meter squared second squared, so that is considered as joules, divided by, we have here 1 minus 0.49, copy the square root, so we have 1 minus 0.49 is equal to 0.51. We have no more units since it is already cancelled out. And just copy 819.9 times 10 raised to the power of negative 16 kilogram per meter squared and second squared divided by, what is the square root of 0.51? So that is 0.714. So let's just divide 8.19 times 9.9 times 10 raised to the power of negative 13 joules, or it could be joules. Alright, it could be joules, divided by 0.714 is equal to 1148.32 times 10 raised to the power of negative 16 kilogram, or that, let's say, joules. Alright, so we have now our relativistic energy. So now we are in joules, so let's do the dimensional analysis in order to convert from joules to EV, or electron volts. We have 1148 times 0.32 times 10 raised to the power of negative 16 joules. So it cannot be, so let's get another paper. So here 1148.32 times 10 raised to the power of negative 16 joules. Alright, so let's get the equivalent. So we have in 1 electron volts, we have 1.60 times 10 raised to the power of negative 9 joules. Alright, so we have joules, so cancel out joules. So we have 1148.32 times 10 raised to the power of negative 16 times 1 divided by 1.60 times 10 raised to the power of negative 9. We got the answer of 71.77 times 10 raised to the power of negative 24 electron volts. So we have now our answer of the first problem. Therefore, 71.77 times 10 raised to the power of negative 24 electron volts is the total energy of an electron that moves with the speed of 70% speed of light. Alright, so let's move on to the problem number 2. We have calculate the total energy and the kinetic energy and electron volts of a proton moving at a 65% speed of light. Alright, so we have here, we are going to identify the given values. So we have the speed of light, that is 65. So velocity of 0.65 c. And we have a proton that we all know the mass of a proton is equivalent to 1.67 times 10 raised to the power of negative 27 kilogram. Okay, so let's find the relativistic energy and its kinetic energy. Okay, so before arriving or answering the kinetic energy, let's start first in solving the relativistic energy. So again, we have a formula of getting the relativistic energy, which is energy is equal to mc squared divided by the square root of 1 minus the v squared divided by the c squared. Next, let's plug in the given values. We have now the mass, which is the 1.67 times 10 raised to the power of negative 27 kilogram multiplied by the speed of light, that is 3.00 times 10 raised to the power of positive 8 meter per second. And let's going to square that, divided by, just copy the square root. We have 1 minus v squared. What is the equivalent of v? That is 0.65 c divided by the c squared. Alright, the squared. So again, 1.67 times 10 raised to the power of negative 27 kilogram. And let's square the speed of light, so that will be 9.0 times 10 raised to the power of positive 16 meter squared and second squared. Alright, so divided by the square root of 1, and we have 0.65 multiplied by itself is equal to 0.4225, and c multiplied by c is equal to c squared, and copy the c squared. So let's cancel out same units, and then we have now here so 1.67 times 10 raised to the power of negative 27 kilogram multiplied by 9.0 times 10 raised to the power of positive 16 meter squared second squared is equal to 150.3 times 10 raised to the power of negative 12 kilogram meter squared second squared, or that is joules. Alright, so the square root of, just copy the square root, so we have 1 minus 0.4225 is equal to 0.5775. So let's get the square root of 0.5775. So we have here 150.3 times 10, just copy, joules divided by, so we have the square root of 0.5775 is equal to 0.76. Right, so Let's divide 150.3 times 10 raised to the power of 12 joules divided by 0.76. That is 197.76 times 10 raised to the power of negative 12 joules. So we have now our relativistic energy. So we're going to make this into electron, mega electron volts. So that is mega electron volts. Alright, so our problem is missing. So we have here mega electron volts. So we have here 197 0.76 times 10 raised to the power of, so again let's get another piece of paper since it is not fit to this scratch paper. So we have here 197.76 times 10 raised to the power of negative 12 joules. So now we have times. In 1 electron volts, we have 1.60 times 10 raised to the power of negative 19 joules. That is equivalent to 1236 times 10 raised to the power of negative 32 electron volts. So from 1236 times 10 raised to the power of negative 32 electron volts, let us going to convert it into mega electron. In 1 mega electron volts, we have 10 raised to the power of 6 electron volts. So cancel out. So again, cancel out. That is 12.36 times 10 raised to the power of negative 36. Okay, so now we have here mega electron volts. We have now our mega electron volts, the relativistic energy. So let's now use our kinetic energy to solve the kinetic energy in mega electron volts. So we have so kinetic energy is equal to 1. Kinetic energy is equal to the relativistic energy minus the ME, or the mass of an electron or either the proton, depends upon the given problem. So ME, the c squared, the speed of light that is being squared. So we have now our energy, that is 12.36 times 10 raised to the power of negative 36 mega electron volts minus 1.67 times 10 raised to the power of negative 27. That is the mass of the proton. And the c squared, or the 3.00 times 10 raised to the power of 8 meter per second. That is being squared. That is being no, that's just that. So we have 12.36 times 10 raised to the power of negative 33 mega electron volts minus. So we have now here 9.0 times 10 raised to the power of negative 16 meters squared second squared. So we have 12.36 times 10 raised to the power of negative 36 MeV minus, we have here 1.67 times 10 raised to the power of negative 27 multiplied by 9.0 times 10 raised to the power of negative 16 meters squared second squared. So that would be negative 150.3 times 10 raised to the power of negative 12 joules. Right, so in order for us to subtract these two, so let's first convert joules to MeV. So we have here negative 150.3 times 10 raised to the power of negative 12 joules. So this is a dimensional analysis. So we have in 1 electron volts, we have 1.60 times 10 raised to the power of negative 19 joules. So cancel out joules. So we have now volts remained. And from electron volts to mega electron volts, so we have in 1 mega electron volts, we have 10 raised to positive 6 electron volts. So cancel electron volts. So we have negative 150.3 times 10 raised to the power of negative 12 multiplied by 1 divided by 1.60 times 10 raised to the power of negative 19 times 1 divided by 10 raised to the power of 6 is equal to 2.97 times 10 raised to the power of negative 36 mega electron volts. So we have now our kinetic energy in mega electron volts of a proton, that is 2.97 times 10 raised to the power of negative 36 mega electron volts, that is moving at 65% the speed of light. Right, on this video, you have learned about the relativistic energy and the equivalence of mass and energy. Thank you for watching, everyone.